Hello everyone, my name is Leanne Cameron and I'm Senior Lecturer in Education at James Cook University in Townsville. Today I'd like to have a quick discussion with you about core concepts of the technologies curriculum. Core concepts are the big ideas, understanding, skills or processes that are essential to the technologies curriculum. The diagram on the left-hand side may be new to you. The words core concepts may be new. You might be more familiar with the key ideas as shown at the top of the screen. However, in the consultation curriculum, we're looking at core concepts. So creating solutions for preferred futures is the overarching core concept and involves identifying compelling visions of the future and making considered design decisions, taking into account economic, environmental, and social sustainability factors. So the idea of creating preferred futures is not very different. The focus is just ever so slightly different in the new curriculum. If we have a look at the diagram, you'll see that the creating solutions for preferred futures still encompasses everything else. But as we work towards the centre, you'll see that we've got technologies there at the core, right in the middle. We've then got systems, data, interactions, and impact. And then surrounding that, we've got the systems thinking, computational thinking, and design thinking. On an outer layer, we've got enterprise and innovation, technologies, processes and production, and project management. So as I said, I'm going to concentrate today only on systems thinking, computational thinking, and design thinking, with a little bit of project management thrown in there. So I'm going to use this particular example to illustrate how those thinkings might be undertaken in a classroom situation. So it's how an autonomous car sees LiDAR. Now there's a link there to a video that if you want to follow this through and understand the context of what we're talking about here, that link there will be made available on the PowerPoint, which you should have access to. But there it is there. We haven't got time to play it now, but it does explain how an autonomous vehicle works, how it sees, if you like. Now, the reason I use this particular example is it's something that a lot of people are very excited about. A lot of people are concerned about. It gets people really thinking about it. And more importantly, most people don't know an awful lot about it. So we're going to start with systems thinking. So systems comprise the structure, properties, behaviour and interactivity of people and components within and between natural, managed, constructed and digital environments. So when we're looking at systems thinking helps people to think holistically about the interactions and interconnections that shape the behaviour of systems. So what that means is that we want the students to really think about the big picture. We want them to understand that whatever solution they can come up with, it will interact and have interconnections with other things. So we want them very much to understand the impact of what they're doing. So let's get back to our car, the autonomous vehicle. So first of all, after watching that particular video, that entry event, we would then ask students to identify the subsystems of an autonomous car, to make them understand that there's lots and lots of systems within the car. Now, we're only going to give them about 4 minutes for this, and it's important that they're in a group of about 2 to 3, maybe 4 at the most, to have this discussion so that they all start thinking about it. The next step is getting the groups to report back. Again, a fairly quick process. We want everybody thinking about this topic. We get them to identify the subsystems, think about all the things and how they interact. And then finally, we pull it all together. So we have a summary ready to ensure that they've got full coverage. So the idea of all that was for them to understand that within this car, there are lots and lots of systems, subsystems, and they all have to work individually to do their job, but they all work together. So the whole thing will not work unless an eye has been kept on the big picture. So that gives you an idea of how systems thinking might be stressed. And now I want to have a talk about design thinking. So design thinking helps people to empathize and understand the needs, opportunities, and problems. Generate, iterate, and represent innovative user-centered ideas and analyze and evaluate those ideas. I like this diagram when I'm talking about design thinking. It's from Stanford d.school, and if you haven't visited their design thinking webpage, I highly recommend it. And the reason I like this particular diagram is because it starts with empathize. And that's a key component of what we're talking about, and really important with students. They often don't think or recognize that others think differently to themselves. So we need them to very explicitly run through this part. So let's get back to our problem of the autonomous vehicle. So the task is to design the interior of an autonomous car for an elderly couple. So we have to get the students to empathize with this elderly couple. So we have to get them to think about the characteristics of a typical client. So individually, that is, each one of them should be thinking about this for a minute. We want everybody to make a contribution. We want them to be thinking about this. Now, take care at this stage that they come up with characteristics like perhaps difficulty with mobility, rather than solutions, which would be make the doors open wider or bigger or whatever. So make sure that they focus on the characteristics, not the solutions at this point. We then get them to discuss in groups of, say, 4 to 6, all these characteristics and come up with a whole lot of a list in each group. Now, they've only got about 4 minutes to do this. So you'll note that I've put the time that I give these students each of these activities, mainly because I want you to understand that this is a really, really short process. We then get all the groups to report back to class. Again, a very quick process, get them all down. Don't repeat them if they've already been said. And that way we have everybody thinking again about this problem and the characteristics. So that's the empathize stage. We then move to the define stage. So through the discussion of working out what this elderly couple, the characteristics are, what their needs might be, we start to define this problem. But the definition, the defining continues to be clarified throughout the whole process. We then start our work on ideation. So we individually ask every student to sketch the interior of an autonomous car for an elderly couple. So they already know what the needs are. We need them now to put their ideas on paper. And again, it's really important that every student does this. Now you might think, oh, that's really hard to do. How do you draw an interior of a car? Just a rectangle with, loose symbols in it, with labels if the students are really, really not good drawers. But again, we're only going to give them about 6 minutes for this. So this doesn't give them a lot of time to do wonderful drawings anyway. So the difference between the great ones and the not so great ones is not emphasized here. Very quick, rough drawings, that's all we need, just getting the ideas down on paper. Now we ask everybody to just leave the paper where it is and walk around, and everybody gets to view all the sketches. Now, this is a bit difficult for some students because all of their life we've been told they aren't allowed to copy other people's work. But in actual fact, in design, out in industry, they work in teams all the time. So you look and see what you think are great ideas that others have. And that's how you really start working to improve your own work. So then everybody goes back and improves their sketches using and modifying from what they've seen of other people's work. Now we get back to group work. So usually in about groups of 4, we want to get them to really visualize what this looks like. And in design, it's been shown that visualization is a really powerful tool. So we get them to actually do a prototype, a model of what their interior of the car looks like, just the interior. So again, start with the rectangle and put the things on top. This is only about 20 minutes, so it has to be really quick. That's why I really like using Play-Doh. Play-Doh, they can manipulate things. They can have a discussion about whether this works or that works. The group of 4 is really important because they'll all have come with individual ideas and they'll have to justify why they think their ideas should work. So it gives a really good, rich learning experience. One that sometimes has to be massaged a little by the staff in the room, but usually it works quite well. But note again, we're only giving them about 20 minutes, so they can't take too long. They can't make it beautiful. They can't invest a whole lot of time in this. It's just the ideas out there. So this is that prototype stage. So at this point, I'd really like to discuss the process that's going on here, to get students to think about their response individually so that they have empathized with the user, the end user. Then they brainstormed their ideas in a group of 4 to 6. That's where they ideated. They then shared with the whole class so that everybody got the benefit of all the work being done, and then sketched the ideas individually to get all those ideas on paper. Everyone walked around to see what everyone else had, benefited from the great ideas they saw, might have discarded a lot of ideas of others. They chose the ones they wanted, revised their sketches individually, modeled their ideas then with a group of about 4, which gave them the opportunity to really visualize what this design might look like. And then they present the model. So everyone walks around, looks at the model's presentation, and then they've got the opportunity of going back and revising the prototype. Now, if you get the opportunity to test with clients, then that should be done throughout the process, and it's never too early to start testing with clients. But this whole process is this very rich design process. Now, some teachers say, I don't have time to do that, I really need them to get started on their work. If you add up all the times that we've put together here, it's most likely going to take you less than an hour. And the quality of the work that you will get from this process, I can guarantee you, will be much better than giving your students just just a little bit of extra time with their designs. So design thinking really draws on every single student's experience, creativity, skill, regardless of their gender, regardless of their cultural background, regardless of their belief in themselves as a designer. It gets everybody actively participating in the whole designing and development process in a whole range of different ways. And the innovation and the creativity comes, and you get them trained into this way of thinking, like an entrepreneur. This has long-term benefits to these students. Throughout the whole process, they'll be naturally developing and demonstrating technology-related knowledge and understanding and processes and skills. So this is where your content comes in, just naturally happens. And on top of that, these problem-solving dispositions. So students start to build up this resilience that we know they need throughout their whole schooling career. And they can do it in a whole range of technologies contexts if the problem is good enough. And importantly, they learn to work in this lifelike situation of teams, manipulating things, negotiating. Hugely beneficial long term. These are the things that employers say that some of our students are not doing well at this point. And they're working on real needs and wants of real clients so that they might create solutions for their preferred futures. The third thinking is the computational thinking side. Now, computational thinking is not thinking like a computer. Computational thinking encourages people to organize their data logically by breaking down problems into parts, defining abstract concepts, and designing and using algorithms, patterns, and models. In fact, if you're working with a computer, you usually have to use computational thinking before you can even give the computer the data to work on, because you've got to take this abstract idea of this problem and break it down so that a computer can actually work with it. So it's a really important part of being successful when it comes to problem solving. So here are the major elements of computational thinking. And I want you to think about how many of them would just have naturally occurred during that design exercise that we just did. So decomposition, which is breaking down tasks into smaller and more manageable parts. So think about that problem we started with and then broke it down into these little parts for students to work on. Data analysis, making sense of data, finding patterns, drawing conclusions. Again, the students would have been doing that as they worked through. Things like they might have done a survey in the beginning to find out what users really wanted. That's the perfect example of that. Abstraction, reducing complexity by defining a main idea. I'll come back to abstraction because it's something that people often have trouble with, and I'll give you an example that might help you understand what that means. Algorithm design, if they're going to put this into some sort of computerized form, they'll need that. But basically, algorithm design is just designing a series of ordered steps to solve a problem, and that's what design thinking process is. And then transforming, solving new problems using existing solutions. Students need to evaluate their problems and their solutions, and then be able to recognize how that might be used in the future. So here's an example of abstraction. So on the left-hand side, there is a Google map of Townsville. And on the right-hand side, there's the more familiar maps that we use. If I said to you that I wanted you to walk from Townsville Magistrates Court to the goat track at Castle Hill using the map on the left, then all the information's there. There's no problem with that. It's just absolutely correct. However, it's really requires a bit of concentration. If I said the same thing of the map on the right, I suspect you'd find it much easier. And it's because all the extraneous information, the redundant information has been taken away from the one on the left to create the one on the right. So sometimes problems are much more easily solved if you take away all the information that's not useful. So that is abstraction. So I hope that you have now got a better idea of what systems thinking looks like, design thinking, and computational thinking. And I just want to very quickly touch on the fact of this is much, we're encouraged to deliver all of this using project-based learning in projects. So take care that you know the difference between a project and project-based learning. So if your final assignment for a unit of work is just a research project on household waste in Australian homes, for example, that's doing a project. However, if the project is totally the unit of work, and what you've got to start with is how might we reduce the amount of landfill our household produces, and everything you do is working towards solving that, then that is project-based learning. But that requires a fair bit of project management. Now, project management skills help people to successfully and efficiently plan, manage, and complete projects to meet identified criteria of success. And this is something that we really have to work on with our students. Now, without really good project management that can be partially done by the students themselves when it starts in the early years, right through to where they're able to manage projects themselves without as much direction from staff. In the later years of school, you want to be very careful you don't end up with this situation. If you look at the students starting on the right, spending lots and lots of time doing the foundation work and then running out of time and ending up with what's on the left. So project management is key. If you want to follow this up, then the examples that are provided at PBL Works is my recommendation at first, PBL Works. And using project management, incorporating all of the thinking skills into your projects, you'll find that you cover the core concepts of the technologies curriculum really easily. I'm happy to take any questions at all. Thank you very much.